Here is a graph of a quadratic function. Here's another graph of a quadratic function. This is another graph of a quadratic function. All of these functions were graphed by using a table of values and an equation. Let's look at an equation for a quadratic function and how we can create graphs just like this one. The most basic equation for a quadratic function is y equals x squared. Now, the first thing you do with any equation when you're going to graph it is you need a table of values so you know what to graph. So let's create a table of values so that we can graph this function. We can start with x is -2. -2 squared is a positive 4. Next we can use -1. -1 squared is a positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. You may already notice a pattern of values in the y table that's going to affect the graph. Now let's graph these points and then let's take a look at what the graph looks like for a quadratic function. Here's our coordinate grid. Now let's graph these points. Here's the graph of this quadratic function. When we have a graph that is shaped like this, we call this U-shaped graph a parabola. And when you see a parabola, you can know automatically that you are dealing with a quadratic function like this one. Now let's take a look at another equation and see if we can graph that parabola. Y equals 2x squared. We start with a table of values. -2 squared is 4 times 2 is 8. -1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is still 0. 1 squared is 1 times 2 is 2. And 2 squared is 4 times 2 is 8. Now we can graph this function. Let's graph it in red. Here is the parabola for this function, and now it has been graphed. Let's look at one more where there's a negative value involved and see what happens to the graph of the function. Y equals -3x squared. Let's start with the table of values. We have an x and a y value. If x is -1, then y is -3. If x is 0, y is 0. If x is 1, y is still -3. Now let's graph these points and see what happens to our graph. Notice that when we graph this parabola, that the graph is actually upside down. When we have a negative coefficient, as we do here, our parabola is going to face down instead of facing up. Take a look at these graphs and see if you can determine whether the parabola would be an open up or an opening down. This graph opens up. It would have a positive coefficient. This one opens downward. It would have a negative coefficient. Using what we have learned, you've now learned how to graph and identify quadratic functions.